All right, well then let's introduce these relational databases. So relational database is what is a super popular way of storing lots of data. Like this is what the Twitters of the world, the Googles of the world, the Metas of the world use to store some of their data at scale. There are alternatives to relational databases. Indeed, today we'll talk about a language called SQL. There's also a movement, if you will, or an alternative generally called NoSQL, which is just the opposite. You don't use SQL. There are things called object-oriented databases and the like. But if you've ever heard of MySQL or PostgreSQL or Microsoft SQL Server or Oracle or MariaDB or a bunch of other products, both free and commercial, this is what they're talking about. Databases that are designed to store lots of data. And what's nice about relational databases is that they're really similar to the spreadsheets with which you were presumably familiar long before today's class. So a relational database is going to store, as you'll see, all of the data in rows and columns. Now, the terminology will thereafter be a little different. Instead of having sheets, you're going to have tables. But those tables are still going to have rows and columns. And you're going to have even more control over the performance of your data when you start to access it using this structured query language, or SQL. This is a language you can use for web apps, mobile apps. A lot of analysts would sit down at their Mac or PC and actually ask questions of data to get back the answer. And wonderfully, even though there will be some new syntax today, SQL really just does 4 basic things. CRUD is the sort of crude acronym here. CRUD is a way of remembering that a relational database supports ultimately creating data, reading data, updating data, and deleting data. So even if you're feeling like, wow, this is a lot of new syntax, which it isn't relative to our past languages, the only things you're doing really are creating data, reading data, updating, and deleting the same. Now, a little confusingly, in SQL, the corresponding functions or commands that exist that map to CRUD are actually this. So it's still create, but there's another one called insert. It's not read, which is more of the computer scientist way of saying it, but select, which is a little more explicit, like select data you care about. Update is still update. Delete is still delete. But there's another command called drop, which lets you drop, that is, delete entire tables as well. So you can create tables using syntax that's generally going to look like this. You'll say create table. You'll give the name of the table, which you can call most anything you want, but generally all lowercase, no spaces is best. Then in parentheses, you can specify a comma-separated list of the columns that you might want in this table. So this is the code equivalent in the SQL language of like manually opening Google Sheets or Excel or Numbers and like clicking in the top left cell and like typing timestamp. And then in the next, typing language. And then in the third, typing problem. This is the way to sort of define what your headers are, if you will, in a spreadsheet, but now it's called a table. Now, we won't use this command manually first. Let's do something a little simpler. We're going to start off by just importing this data ourselves. And I'm going to go ahead and do this. Let me go back to VS Code here. I'm going to leave behind favorites.py for now, because now we're going to transition to this other language called SQL. And to do this, I'm going to create a new database file. And I'm going to do so using a command called SQLite3, which is just the 3rd version thereof. And I'm going to give the database a name of favorites.db. There's different conventions, but this is one of the most common. When I hit enter, this is going to create for me a new empty database, just like opening an untitled spreadsheet in Excel, Google Sheets, or Apple Numbers. I'm being prompted, do I want to create favorites.db? I'll hit Y for yes. OK. We're up and running. Now, you're going to notice a different prompt. I'm not in my Linux prompt per se, which is always the $sign. I'm now inside of the program called SQLite. And we're going to use SQLite, SQLite3, as just an interactive way for now of playing with SQL code. At the end of today, we'll show you how you can use SQL in Python code so that you still write Python code to do whatever you want, but you can talk to databases using Python. And this is exactly how web apps, mobile apps work. For instance, on iOS, on an iPhone, an iPad, or the like, if you want to store data, it's very often stored in a SQL database, as we're about to do. But you might use a language called Swift or Objective-C. And the same exists in the world of Android using Java or Kotlin or something else to query the database. So we're going to see SQL in isolation for now. Like an analyst might just use it at their Mac or PC, but we're going to tie it together by day's end. So at this terminal, SQLite, let me go ahead and execute this command first. I'm going to first put SQLite into CSV mode because I'm going to cut some corners initially. And I'm just going to automatically import all of the data that was submitted via that Google form, which I exported as a CSV and uploaded to my code space. And I'm just going to automatically say, turn this CSV file into a SQL database for me, just so I don't have to figure out what those create table commands are. So to do this, I'm going to say mode CSV, so that SQLite knows that this is the command, knows that this is a CSV file. It's literally dot mode, so the dot comes before the keyword there. And now I'm going to say dot import, and then the name of the file I want to import, which is favorites.csv. And now the name of the table that I want to create with that data. And just for consistency, I'm going to call it favorites. I could change these things to be anything I want, but I'm going to do that. And voila, nothing seems to have happened. But just like in C and in Python and Linux, when nothing seems to happen, that's usually a good thing. It means I didn't mess up. So if I want to see what just happened, there's this other command. And these commands that start with dots, these are SQLite specific, which is indeed a lightweight version of SQL. They're not SQL per se. So if you're using Oracle or something else like that, you're not going to use these exact commands. You'll see the ones we use in just a moment. And here's the first. When I type .schema, the schema of a database is the design of the database. What are the tables? What are the columns? And all of that. So when I type .schema, this actually, in this case, shows me the create table command that was automatically run for me by just doing this import line. Once I get more comfortable with SQL, I could literally type this out myself or use some program to generate that as well. But what it's creating for me is this: create table. If it doesn't exist, even though it's more terse than that, I want to create a table called favorites. And then the columns for that table are going to be timestamp, which is going to be text, comma, language, which is also going to be text, comma, problem, which is also going to be text. That was just inferred very trivially by the dot import command to just figure out that, yes, just give me a 3-column database table based on the Google form. Okay, questions on this? These are commands you run once to get up and running. You don't run these commands frequently. But we have them on the slide just for reference. All right, so now let's do something a little more interesting. I'm going to clear my SQLite terminal here, but I'm still in SQLite. I'm going to now use some of my first SQL commands, which recall were among them select. So CRUD, C-R-U-D, the R was select. This is maybe the most common, the most useful, the most powerful thing to use with a SQL database, selecting data to answer questions akin to the ones we were trying to answer with Python. This is the general syntax. Anytime you want to select data from a SQL database, you literally say select. You then specify the column or columns that you want to select data from. You literally write the word from, and then you specify the name of the table you want to get that data from, semicolon, in this case. Everything that's in capitals here is a SQL keyword. Strictly speaking, you don't have to capitalize things, but we would encourage you to do so stylistically. And especially as you're learning and even as you're writing it, it just helps to distinguish SQL from like words you chose, like the names of the columns and the data they're in. So do adopt early on this convention. So let me go back now to my code space here. I'm running my terminal window with SQLite 3 inside of it. Suppose that I just want to get all of the data from the favorites table, which was automatically imported. Let's do this. Select. I want everything. Well, I can do timestamp, comma, language, comma, problem. But you know what? Here's a convenience already. If you want everything, there's what's called a wildcard character in SQL, which is just a star, an asterisk, which means give me every column without my knowing even what they're called. Let me go ahead now and say from favorites, semicolon. And this is the SQL way of opening the database, iterating over every row they're in, printing out every row they're in, done. So those 3 steps, which was like 9 lines of Python code, give or take earlier, is now 1 line of SQL. I hit enter. There is all of the data. So I see now all of the data just outputted as a CSV here. But it's not the CSV file. It's now actually the table. And in fact, just for good measure, let me do this, because you'll see the behavior a little differently the next time we open the file. I've just exited out of SQLite 3. I'm going to rerun it. But I'm not going to re-import the data or do anything like that, because my file now exists. In fact, let me take one step back. If I type ls at my Linux prompt, there's my favorites.py from before. There's my favorites.csv from before. And here's a third file that I did create a moment ago when I first ran SQLite 3. So the data is persistent. It's not using RAM or memory. Anything I do now is saved there. So let's go ahead and rerun SQLite 3 with the same file. But I don't have to re-import everything because the file already exists. Let me now do that same thing again. Select star from favorites to get all of the data. And what you'll see now is the same data, but it's a little prettier now. Because I reran it, I effectively disabled CSV mode this time. And what I'm now seeing is the entire contents of this database table called favorites. Now, there's nothing new here, but you're just seeing now like an ASCII or Unicode version of all of the same data from that database. Well, suppose I want to get a subset of the data. Well, let me clear my screen. And just like in Linux, I can hit Control-L just to clean things up aesthetically. Suppose I want to get just the languages. So I could do select language from favorites. And this will now select not all 3 columns, aka star. This will only select the language column and all of the data therein. If I hit enter, voila, now I just see those there. No timestamps, no problems. It's just a slice of the table, if you will. All right, not that interesting still, because it's just a big column of data. But now things get more interesting. It turns out in SQL that there are functions that come with this language, just like C, just like Python. In SQL, some of the more useful ones, some of the simpler ones are these here. Average, count, distinct, lower, max, min, upper, which pretty much do what they say. And count is a particularly useful one. Let's start with that. You know, it's a reasonable question to be asked, how many people submitted the Google form by the time I actually downloaded the CSV? Well, why don't we go ahead and do this? Let me go back to VS Code here in my terminal window. Let me select not star, but the count of star. So give me the count of the rows that are being returned from the database called the database table called favorites. Now when I hit enter, I'm not going to get all of the data. I'm just going to get simply a number. 430 rows came back. So that's pretty good. I now know how much data is in there. Well, what languages were in there? Well, I could do select language from favorites just as before, but that's not that useful, especially if I'm inheriting the data. Like I'm the analyst who's been handed a data set by my boss, and they want me to like crunch some numbers. OK, I could like load this into Excel. I could sort it. But you can use SQL now to answer pretty basic questions too. If you want to select the distinct languages in the data set, because you weren't privy to the Google form, let me go ahead and select only the distinct languages from the favorites table. And now I hit enter, and I get back a much more succinct answer. Just the 3 languages in question. Not really that useful since I created the Google form, but certainly if you're inheriting data from someone else, you've just downloaded a data set, at least now I'm arguably wrapping my mind around what's going on. Now, this is not necessary for such a small data set, but I can combine these things. Select the count of the distinct languages in this data set called favorites, and now I should get back what answer? So hopefully, indeed, an answer called 3. And what you're getting back, notice, aesthetically too, is like a mini temporary table. When I asked for just the distinct languages, what SQL hands me back is this temporary table in memory that has 1 column called language and then 3 rows. Now, this is not saved anywhere. It's just executed ephemerally like this. But that's why it's depicted in this way. What you're getting is subsets of your data, smaller tables containing some of your data. And same thing down here. This is like a crazy long column name. You can rename it if you really want. But that's all we're seeing there. And in fact, if that's a little ugly, we can actually alias these things. N is a common name for a variable, a number in any programming language. So I can actually alias this to be a column called N. Hit enter. And now I'm getting a tiny, tiny table whose column is called N that just has the 1 value there. All right, questions on these application of these functions here? No? Questions? Yeah. Say a little louder. Oh, as, so literally in English. So rename this column as this. Technically, it creates an alias for the column. So that's all. Yeah. Exactly. Distinct will operate on whatever you handed in parentheses and get rid of all of the duplicates, giving you back just the uniques. Correct. Other questions here? Yeah.
When n becomes an alias in the table, does that become someone's a variable you can call back to later on in the program?
Good question. When you define an alias like n, which I just did, does it become like a variable you can reuse? Short answer, no, in this case, but you can reuse it within your same query. Even though these queries are getting a little longer, admittedly, statements that they are, you can actually reuse n in even longer queries, so later in your query. And we'll see a few that are going to start to grow in length. So it's a nice way of nicknaming things just to be a little more terse in your query. So we can transition to some of these more sophisticated queries because it turns out there's some other techniques we can introduce as well. Here are some other keywords in SQL. And again, even though like this is another list of things, there's only 4 things fundamentally we're doing: creating, reading, updating, and deleting data. These are just allowing us to like fine tune how we do it exactly. So where is going to allow us to filter data, as we'll do in just a moment. Like select data where this conditional is true. Like is going to be an alternative to an equal sign. So instead of looking for exactly Scratch or exactly Python or exactly C, you can look for something like ... And it can be a little bit of a fuzzier match, if you will, with other characters as well. Order by is going to deal with sorting. Limit is going to just let me limit the total number of rows that come back to 1 or 10 or finite if I don't want to see all 400 plus rows all at once, because I'm just trying to wrap my mind around it. And group by is best shown by example. So let's play with just a couple of these as well. Let me go back to VS Code here. I'll clear my screen. I'm still in the same SQLite instance. And let's count how many of you liked C without writing Python code as before. So let me go ahead and select the count of the rows from favorites where the language in each row equals C. And the convention in SQLite is to use single quotes anytime you're surrounding a string that's meant to represent a literal piece of text, as opposed to C, which was double quotes, or Python, which was either. So this is selecting the count of rows from favorites table where the language in question is C. Enter, and this gives me 98. Notice, though, if I omit that predicate like we did before, you'll get back the total number of rows that were in the table. So where is what's called a predicate that just allows me to filter things, just like an if condition or the like in a language that we've seen before. You can be a little more specific, like how many people really liked C and the Mario problem specifically. Well, let's do this. Let's go ahead and do select the number of rows from the favorites table where the language is C. And, so it's still literally the word ands and or, just like in Python, but not like in C. And problem equals Mario. So let's see if there's any fans of both C and the Mario problem. And 3 of us really like those 2 things together in this case. All right, what else can we do? Well, more compelling might be to see, kind of like in Python, for each language, what was the popularity thereof? And at the moment, we don't really have a way of doing that except in Python, where we had the loop and we had those variables with the dictionary that did all of that counting for us. You know, totally doable, but tedious, especially if your job is to analyze data. My God, like even writing 15 lines of code to answer simple questions is kind of ridiculous. SQL can do better for us. So let me go ahead and do this. Let me go ahead and select every language and the count thereof from the favorites table, but this time group by language. So this was another one of the keywords that we can use in this abbreviated list of extra features of SQL. And this one's takes a moment to wrap your mind around, but this is going to give me a 2-column temporary table where the first column is a language and the second column is the count thereof from this data set. And group by language just means that only show me Scratch once, only show me C once, only show me Python once. That is, group all of the identical values together, but keep track of how many of them there are. And so now, if I go over to SQLite and I hit Enter, now I have, in SQL version, the exact same output that I had from Python that took me, 15 plus lines before. Now we're down to just 1, because SQL, structured query language, is all about constructing queries like this to answer questions and get back answers quickly. If we want to clean this up a little bit, you asked earlier about sorting order. Well, we can do that too. There's another key phrase we can use here. We can order by the count of those rows and then run that query here. So now, unfortunately, they're from smallest to biggest, but we can reverse that. It turns out, and my query is starting to wrap here. I'll zoom out for a moment. if you want to order by count, the default is in ascending order, abbreviated ASC. If you want to reverse the sort in SQL, instead of using reverse equals true like we did in Python, you say DESC for descending order. And now we get almost the same output, but flipped in reverse. So it's just a lot faster to answer questions once, of course, you get some muscle memory and some comfort with it. Well, what else can I do? You know, what if I just care about the most popular language? I don't care about the second place or the third place languages or anything else. Well, let me add one more clause here. Limit the answer to 1. And no matter how many rows should come back now, I just get the number 1 language as of the data set we collected with 270 votes for it. Questions on this? Any questions here? No? Well, what if, you know, we're starting to introduce SQL, and it was kind of too late to make it into the Google form. So it turns out there's syntax for this, too. You can create data, of course, not just the tables, but the data they're in. And here's like the typical syntax for inserting data into a SQL database. You literally say insert into the name of the table. And then in parentheses, you specify one or more columns for which you have values that you want to insert. This is to say, you don't have to give values for every column in the given row. If you only have answers to some of those questions, you can enumerate them here like this. But the values you insert are going to be these. So you literally say after the closed parenthesis, values, and then in a second set of parentheses with the same length comma separated list, you specify what values do you want to insert. So it's a little verbose. And frankly, longer term, you're going to use like Python code to automatically do these kinds of insertions. But let's go ahead and try this. Right now, if I do select distinct language from favorites again, we see this, just these 3 candidates. But we've now taught you a bit of SQL, so let's do insert into favorites, the column called language. And you know what? I'm going to give a problem here. The values for which, and let me zoom back out, are going to be quote unquote SQL and quote unquote 50ville. You'll soon see what that's all about. Semicolon. Nothing seems to happen, but that's usually a good thing. And now if I scroll back up in my queries, in SQLite 3, you can scroll back and forth in time and, to avoid retyping things. Now I should see, indeed, 4 candidate languages here. Now suppose that you were never really a fan of C, and maybe you programmed a little bit in high school or in the real world, and you liked C++. Well, there's a whole lot of answers for C. So select star from favorites where language equals quote unquote C. So here's everyone who submitted the answer for C. Let's presume that no, they didn't really want C. They wanted C++, which is not a language we teach in the class. But I could also now do this. You can use the update command to set a column or columns to different values where some condition is met. So if I do update table name, set column name equal to some value, filtering it perhaps by where some condition is true. So suppose I've changed my mind, or you know what, let's go ahead and do update favorites, set language equal to maybe C++ where language equals C. Now this is destructive, so you generally don't want to do this unless you have a backup of your data too, overriding what people's answers are. This seems to have been successful because no error messages. And if I rerun the previous select, that gives me all of the favorites where language equals C. Now indeed I get none. But if I search for C++, now I get a lot. And if I get rid of that where clause altogether and just look at the contents of my database, now you see that indeed C++ is commingled with all the other data. This is not what you all intended, of course. So I can undo this. Let me go ahead and undo what I just did. Let me set my favorite language to C, where language equals C++. But the predicate is important. This I'm not going to do. What if I accidentally omitted this predicate, the where clause? How would that screw things up, might you think? Yeah, in back. It would set every row's language to indeed C. And this is dangerous. And if you start Googling around for like SQL mistakes or the like, people in the real world have accidentally run commands like this. And without naming names, a former member of our teaching staff at one point accidentally ran a command like this and changed every student's name in our database to Bobby, I think it was. The same name for every row because they simply forgot a predicate. So here too, like there's dangers in code. And you should adopt the habit quite quickly of always one, backing up your data, like with CP, for instance, in Linux, or any other technique, or just making sure before you hit enter that, yes, this is indeed the query I want to execute. And generally speaking, in the real world, there should be process controls in place, like the intern should not have access to the database, the production database, the live database, and the like. But you have a lot of power now with these queries, so just be all the more careful, because very easily can you do bad things. So let me undo this. Where language equals quote unquote C++, and I'll zoom back out, enter, and now I think we're back in business. C is among the answers. Yeah? Is essentially doing what at the end? It's essentially find and replace. Yes, in like layperson's terms, this is find and replace implemented with SQL. And in fact, the authors of Microsoft Word or Google Docs might very well be using language like this SQL when you go to the nice graphical, user-friendly find and replace box. This may very well be what they're doing underneath the hood. Or, of course, they could be using some other language altogether. There's one last syntax that's worth knowing, delete, which for better or for worse is even more destructive, whereby it allows you to delete rows from tables. It's distinct from drop, which lets you delete tables themselves. This focuses on rows. So suppose that you really, really didn't like, let's say, Tiedemann was a little challenging if you tackle that more comfortable problem. So if you really don't want to even think about Tiedemann anymore, so why don't we do delete from favorites where problem equals, and I won't execute it for real, Tiedemann. This would have the effect of deleting every row, including the language therein and the timestamp, where the student answered Tiedemann. Worse than this would be this. Why might this be bad? OK, chuckling, because like there's no predicate, there's no filter, which means literally this would delete all of the data. So again, with great power here comes great responsibility. Now, this has just been a data set of, 430 rows by us dynamically created. There's, of course, some really juicy data sets in the real world. And one website you might have heard or an app you might have used is IMDb, the Internet Movie Database, which wonderfully makes some of their data available for download as CSV files or technically TSV files, tab-separated values. But what we did in advance of class was download some of that data for both TV shows in the real world and movies in the real world. And what's wonderful about this data set is it's not just dozens or hundreds or even thousands of lines. There are millions of rows of juicy data, TV shows and movies with which most folks are probably familiar, at least with a subset. And we'll see in just a little bit that this data comes in the form of now 6 different tables that we've given you. And the tables in question for today are going to be the people in the TV business, the stars therein, the shows that people are producing and the like. This is a picture we'll revisit to enable you to wrap your minds around what the actual data is. This feels like a good opportunity, though, for a snack. In fact, in just a moment, we have a whole lot of Rice Krispie treats out in the lobby. But if folks could perhaps acknowledge this mini wedding cake here. CS50's own Carter Zenke is getting married this week. So congratulations to Carter as well. Congrats. All right, there's only... OK, there's only one piece of cake in that box, but a lot of Rice Krispie treats in the transept. Let's take 10 minutes, and we'll be back with Internet Movie Database in 10.